Okay, I'm recording. Okay, welcome everyone. Yeah, it's Thursday, August 6th, 2020, and here we are in the midst of our coronavirus pandemic of 2020. So the y'all that don't know me, I'm Stokes McMillan, and want to welcome you to our now virtual First Thursday program. And today we have a really outstanding speaker, Dr. Kathy Sullivan, who's former astronaut and lifetime member of the NASA Alumni League. But before we get to Kathy, I want to pass it over to our president, another former astronaut, Bill MacArthur, for just to say a few words. So, Bill.
Thanks, Stokes. I think hopefully you can see my slide. This will be the last time I actually talk about this, but we'll keep reminding you. And that is, goodness sakes, please renew your dues when they are due, and consider making a small additional contribution. You know, that's where the money comes from that we're using to hopefully inspire the people that are going to replace our future now members. In other words, that's the money we use to provide to the local underserved school districts to promote STEM education. Thanks for giving me that a minute or two to talk. And I do want to absolutely welcome Kathy. And Kathy, thank you so much for joining us.
All right, so now let me tell you, let me introduce our speaker today. It's Dr. Kathy Sullivan. And of course, many of us know her. And she has a long career as a distinguished scientist, astronaut, and executive. And she was one of the first 6 women to join the astronaut corps in 1978. And she holds the distinction of being the first American woman to walk in space. And also her submersible dive to the Challenger Deep Point in the Pacific in June of this year made her the first person to both orbit the planet and reach its deepest point, as well as the first woman to dive to the full ocean depth. And so thus she has earned the title of the world's most vertical woman. And so Kathy has held a variety of senior executive positions since leaving NASA, including presidential appointments to the National Science Board and as chief scientist, deputy administrator, and then administrator of NOAA, the National Oceanic and Atmospheric Administration. And so Kathy has earned a bachelor's degree of science in earth sciences from the University of California in Santa Cruz, and a PhD in geology from Dalhousie University in Nova Scotia. So she's been elected to several Hall of Fames, including she's in the Astronaut Hall of Fame, the Woman Aviators Hall of Fame, the Woman Divers Hall of Fame, and the Ohio Veterans Hall of Fame. And I'm sure she's hoping to get into the eventual NASA Alumni League Hall of Fame, if we ever establish that. But she has many awards, including an Emmy and 9 honorary degrees. And she's the author of the children's book, To the Stars. And her recent book is called Handprints on Hubble, An Astronaut's Journey of Invention. And I just got through reading that, and Kathy, it's an excellent, excellent book. It's got just the perfect amount of technical details for us space people. And I highly recommend it to everyone, and you can Google it and find that easily. And so without further ado, let me hand it over to Dr. Kathy Sullivan.
Well, thank you, Stokes, and glad to see so many familiar faces and names. And I don't claim to recognize any of the couple of phone numbers that are on, but it's a delight to have this chance to visit with you all again. Just one little minor point. It turns out that the Guinness World Records folks distinguish things done within the Earth's exosphere, the environment of Earth, from those beyond the Earth. So they're in the process of certifying me as the most vertical person in the world, because their definition excludes the Apollo guys. I beat Buzz Aldrin by multiple kilometers on the depth I've dived into the sea, but you know, he's got me by thousands of miles in terms of how far from Earth he's been. So it's my little stroke of luck that Guinness looks at it that way, I guess. So what I thought I would do, I'm going to switch over to screen share mode here, pick up the one I want. That's the one I want right there. And hopefully you all can see this. I have to remember how to get this little guy out of my way. There we go. And we'll just go to play. I figured I would spend today just telling you about my dive expedition. Everyone on this call knows probably about as much as I do about my 3 space flights, and a lot more than I do about the flights after 1992. But this is the adventure that I had at the beginning of June. In the foreground on the right, you see this small 2-person submersible. I'll unpack that for you more in a moment. It's called the Limiting Factor. The guy who owns it and commissioned its design named every vehicle that he's working with on these expeditions after science fiction critters or figures from some of the Ian Banks novels. He's a real fan of the Ian Banks stories. The submarine gets out to its dive points on that surface ship you see in the upper left. That's called the pressure drop. And one of the fun little connections for me is its immediately previous life. It was the NOAA ship MacArthur. And if memory serves, when I was deputy administrator, I signed the paperwork that surplused the MacArthur and put her into the yard, available for sale and refit. And Victor Vescovo bought her and refit her to support the operations with the submersible. Fitted her with a state-of-the-art multi-beam sonar that can provide about 5 meter uncertainty at 11 kilometers of depth, which is just crazy if you know anything about mapping depths in the sea. So this is the adventure. The emblem in the upper right is his Ring of Fire expedition crest. And I'll give you a little bit of the backstory on Victor as we go along. The Ring of Fire is the 2020 expedition through the Pacific Ring of Fire, as the name suggests. So it's one of a string of new scientific and awareness campaigns that Victor's operating through 2020. So let me go ahead here. Well, my slide doesn't want to change for a moment. Hang on. There we go. So where were we going? Let's do a little bit of geography. The map view you see on the left is a view of the Earth looking straight down on Antarctica. And it's what the ocean basins would look like if you drained away all of the water down to 6,000 feet of depth. So the brown surface is basically what would be the mud plain that would be left once you drain all the water out. And those little slivers and arcs and patches of blue are what's called the Hadel Zone, named after Hades, the hellish zone. So those are the only snippets of the ocean that are greater than 6,000 feet in depth. And I don't mean or need to call all of them out to you, but I've got an arrow pointing to the southern end of the Marianas Trench, and then an inset on the right that shows you where that is. It's about 800 miles east of the Philippines. It's a couple hundred miles southwest of Guam. And the Challenger Deep is that lower left-hand piece of the trench where it just happens 2 separate pieces of ocean crust are plunging into the trench at that same point, and they're moving on just a different enough angle that they basically open this exceptionally deep spot in this already exceptionally deep curved trench, the Marianas Trench. You get a sense of where what Victor really set out to do when he first built the submersible. He's an equity investor. He's just a Dallas billionaire, made his money in investments. He did a stint as a Navy intelligence officer early in his life, and he's quite an adventurer. So he's someone who has completed the Explorer's Grand Slam. That means he has summited the highest peak on each of the 7 continents, and he skied across the North Pole and the South Pole. You have to ski the last degree, so 111 kilometers. And as he was finishing up his final summit in the 7 summits, it occurred to him, thinking back to his Navy time, that, you know, there's a companion, there ought to be a companion to the 7 summits. It ought to be the 5 deeps. How come we can go to the highest points on the Earth? We ought to be able to go to the lowest points on the Earth. And he decided he would try to do that. And of course, he discovered there were just a few barriers to that, starting with no one actually knew for sure where the deepest points were. They knew they would be in these blue bits that you see on the left, but where in each of those blue bits was not very well known, especially the trench that surrounds Antarctica. You see 2 little patches of blue just to the left of Antarctica. The South Sandwich Trench, no one had ever been to before. The next thing, of course, was there was no such craft that could take you there. So how are you going to do that? And there's no ship that can carry a craft either. So he set about creating all of that. The fact that they didn't really know where the deeps are led him to put the sonar system on the ship, and he turned to an outfit called Triton Submarines to build this limiting factor craft. And in 2019, he did in fact complete a dive to the deepest point, the just now confirmed deepest point in each of the 5 major deep sea trenches. So he holds that world record as well as the Guinness record for the deepest point in the Challenger Deep. I threw this slide in just to remind us all what kind of scale we're talking about here. So the blue wedge on the left is the Challenger Deep, 10,994 meters. That's up until Victor coming along, that would have been 10,994 plus or minus 25. The new measurement, which we're in process of certifying, I've got some of my NOAA colleagues doing it, the independent certification and error analysis. It'll be very close to that, but it will now be down to maybe even better than plus or minus 5 meters. But just for comparison, if you dropped Everest into the bottom of the Challenger Deep, you'd still have more than a mile of water above the peak of Everest. Titanic, which is the deepest point that Buzz has dived to, is just over half as deep, sits on the bottom just over half as deep. You're basically going as far down in the ocean as a transcontinental commercial airliner flies above the ocean. I mean, you know, Bill and I, and as we jet along in T-38s, we're flying sort of this far above the Earth, but you're dropping all the way down into the bottom of the ocean to do this. So that's the scale of where we're going. And contrary to Jim Cameron's assertion, Cameron did a dive in the eastern pool of the Challenger Deep in 2012 in his little 1-person submersible called Deep Sea Challenger. It had been 52 years since Jacques Piccard and Don Walsh took Trieste to the bottom of the western pool before Cameron became the next person to get there in the eastern pool. One of the punchlines of what the system that Victor has created here is the limiting factor in the system that supports it are so reliable and so repeatable. We did 3 dives to the bottom of the Challenger Deep in a week. The ship turned around after 2 days in port, went back out and did another 3 dives in a week. So it's got a little bit of a kinship to the Dragon capsule or the shuttle. It's the first full ocean depth craft that is reliably reusable multiple times. So it's the first craft that lets you sort of go anywhere you want to go in the ocean, kind of when you want to. You know, the other kinship or similarity that I've drawn to it is if I think about how transformative is this capability to the ability we've had beforehand to explore the ocean, the limiting factor is to oceanography like weekly flights to the moon would be to human spaceflight. It's that revolutionary a change of scale. So here you see the focus in on the deepest points at the deepest point. Everything that's brick red in the upper left-hand side is that's the 10,000 meter contour. So the yellows and blues are showing you depths greater than 10,000 meters. And on the right, it's a zoom in from some of the multi-beam mapping that we did while I was at sea of the eastern pool. You can see it's not dead flat, which is what Jim Cameron asserted. Cameron's got a bit of a snit with Victor Vescovo because the instruments on Victor's sub in 2019 measured a greater depth than Cameron reached in 2012. If you know Jim Cameron at all, you know he's not going to take kindly to that. Maybe everybody. Kindly to the depth that he recorded being beaten, and he claimed it wasn't possible because he went down there and he knows it's perfectly flat. And I'm sorry, but the data demonstrate that it's just not perfectly flat. The goal of the dives that we were doing is suggested by the dashed lines that you see there. The triangles show the locations where we were going to drop robotic instrument packages with depth sensors and water sample collectors and acoustic modems. The dashed circles at the left-hand end of the dashed line show where we targeted to land the submersible, and then we were going to make a traverse from along those dashed lines, stop in at rendezvous with each of the landers so that we have intercomparison of instruments and we can refine the depth measurement at each of those points, and then surface at the other circle. So that was our game plan for all of the dives that we were doing on our expedition. So here's a little better look at the back end of the pressure drop. The golf ball up on the pedestal is a high bandwidth. Victor runs his companies when he's out at sea, so he's got a dedicated high bandwidth internet link. I was doing Skype calls and Zoom interviews with media outlets in England and Australia from out in the middle of nowhere over the Marianas Trench. It was really pretty amazing. And this is how you deploy the limiting factor. For a variety of odd reasons, that crane that has hoisted her is not man-rated. And that means you cannot put the divers into the sub up on deck and then lift the whole thing into the ocean. So you swing the sub outboard, you lower it down to where its bottom quarter is resting in the ocean, and you snub it up against those two large fenders. And then we walk out onto the top deck of the sub where you see those silver railings. We walk out on the top deck of the sub across a small bit of a gangway and climb down into the pressure sphere. This is a cutaway of the sub and how it's built. The business end of it, the important part of it from a diver's point of view, is that circular bit in the center. That's a titanium sphere. It's a 1.5 meters, about 5 foot external diameter, wall thickness of 90 millimeters, so about roughly 4 inches, 3.5 to 4 inches. That's what's going to protect you from the 16,000 PSI that will be right outside your window when you're down at 11 kilometers depth. In the upper right, you see the back side. If you cut away from the opposite side that I've shown here, the back side of the sub is where you access all the key hull penetrators. Those two places where you see cables connecting in through the pressure hull. Those are the cables that deliver power and signal from the battery packs into the interior of the sphere. The battery, back to the diagram on the left and starting at the bottom, directly below the pressure sphere, that cylindrical bit is the 150-pound steel pipe that carries you to the bottom. And that's the one that you jettison when you're ready to come back to the surface. The two sort of squarish bits to the left and the right of the sphere are battery packs. Going above those, you see the arms that spread out and provide the structural support for the thruster clusters that let you move in all dimensions. The battery packs and the thrusters are all jettisonable. The battery packs mainly for buoyancy, the thrusters to be able to get clear of any entanglement. And then along the top of the sub, you see a variety of sensors and antennas. There's a GPS antenna, there's an RF antenna, there's acoustic modems, there are instruments that measure salinity, temperature, and depth, which salinity, temperature, and pressure basically, which help you determine the depth and correct for your sound speed profiles through the sea. And then directly above the sphere, you get a sense of the little trunk that you climb down through to board the sub. And I'll show you a bit of that. Here on the left is the trunk. You see the open hatch, and you can see the wall thickness there on the thickness of the hatch. So you climb, you put left foot on the lower black handles, right foot on the uppers, and sort of shimmy your way down the trunk, stand on the top of the sphere, and then drop yourself into one of the two seats. This picture on the right is Victor and me in the sub as we're just completing our pre-dive, the day before dive brief and safety checks. Victor's the pilot. It's a single pilot craft. So Victor is the pilot, a really solo pilot in command, knows the system's cold, having helped build them up. He's got an engineering background in his own right. The folks like me that he was taking along on these dives, interestingly, he termed them mission specialists. But I got to tell you, it was a whole lot easier training flow to sit in that seat as a mission specialist than to get aboard a shuttle as a mission specialist. My duties boiled down to know where your emergency breathing gas is, know where the long-term breathing hood is, know how to drop the surface weight, know how to make radio calls, and otherwise have gear along so you don't get too cold, and otherwise be pleasant company and spot all the scientific things that you can. Outside of the sub, I was, as I mentioned earlier, putting together this independent calibration validation effort to integrate across all of the depth measurement sensors and provide an independent confirmation of the calibrations and the validity and the error budget on the depth measurements. So that's what the sub looks like. This is what it's like getting launched. There's young Ticers, the swimmer for my dive. I'm in the sub on this dive. And that's Ticer trying to secure all the lines and get us ready to be able to surface. So he's riding quite the bucking bronco. Those are very benign seas for being 300 miles from anywhere. Inside the sub tends to kind of rock fore and aft, like broadside to, and it can be a pretty wild ride. I joked it is a sub that has seatbelts because you can pitch front and back so much as you get tossed around in the waves. And I teased Victor that it's a better ride than anything I ever got on at Six Flags. Here's a view from in the water as the sub begins to descend. You get a sense here, those bungee lines that Ticer was trying to secure before we began to dive so that they don't get entangled on anything. I talked through most of what you see here. The 3 viewports are now apparent. And just to the left of those viewports, the vertical black thing you see is a craft robotics manipulator arm, sort of operated in a control and echo. So you've got a mini arm inside the submersible that is echoed out at larger scale on the big arm. And just above that, with a little cable connecting it in, is the first ever full ocean depth 4K camera. So a number of oceanographic scientific vehicles and earlier subs have taken HD video at depth, but 4K, to build a full ocean depth 4K camera that can operate at these pressures was quite an accomplishment. This is inside the sub on our way down. The Nomex suits are a little bit for warmth and mainly as an anti-static measure. You see basically the electrical control panel behind Victor. Between us, you see the hand controller, his primary hand controller for maneuvering the sub. It's pivoted up to be a bit out of the way at the time. It's a 4-hour elevator ride to go to the bottom. And once you're maybe 5 feet, I mean, with the sea state that we had, when the top of the sub is 5 feet below water, it's completely smooth. The wave action is all gone. You don't feel it at all. You just descend slowly, about a meter per second. It gets a little slower as you get further down, but it's about a meter per second on the way down. The distance we're going, I showed you compared to Mount Everest, but another way to think about it is from top to bottom of the from the surface to the bottom of the Marianas Trench is basically the same distance as half the length of Manhattan Island. So if you called up Google Maps and plotted a route from, say, the ferry terminal subway stop at the south end of the island up to the upper right-hand corner of Central Park, that's about the same distance. And Google Maps would tell you their average walker can walk that, twice as fast as we were descending through the sea. So, we checked in with the surface periodically. We cycled the hydraulics on the manipulator periodically just to keep it equalizing as we went down through the depths. Swapped stories. You got a little more acquainted as naval officers and people interested in the ocean. Ate our lunch at 32,000 feet because doesn't everybody eat lunch 32,000 feet below sea level? Tuna fish sandwiches and a bag of potato chips, by the way, plus the Austrian chef aboard, who's just a superb cook. He makes a Hadel Zone strudel anytime anyone who's diving into the Marianas Trench. And so I, of course, had a piece of Manfred's Hadel strudel in my lunch kit as well. We arrived at the bottom as expected. And this is out of my viewport just with a cell phone. You see the bit of sediment that we kicked up just as we landed. You see the manipulator, welcome to the bottom of the ocean. The sort of dimpling and things you see on the bottom, I would call that, as an oceanographer, I would call that a busy bottom. And it tells me that there's actually some fair amount of life, worms and other things that are living in the upper layers of the sediment. So I showed you those dashed lines. Our plan was to stay at our landing point for 15 or 20 minutes so that our surface ship could triangulate on us and get several acoustic modem pings and be sure of our landing location, then to lift up a meter or two off the bottom and start along that transect. Our robotic landers also have acoustic modems on them, so we could ping and get a bearing to them. Here's a little shot cruising along the bottom. These things that look like tumbleweeds moving across the bottom, most of those are sea cucumbers. If you think they look transparent, you're right. At these depths with no light, it doesn't make biological sense to invest in having pigments. So most of the critters that you'll see down here are translucent or albino. I'll run that again just because it's kind of interesting thing to see. Everyone on this call will appreciate why the main way that I described this scene was as a moonscape. It really did remind me of some of the video that I remember watching as a youngster and then seeing again in my NASA years from some of the lunar flights. It's more tan than the lunar images. And as you'll see in these last bits, we'll go through one more time. You can see some streaking sort of roughly along the path that we're maneuvering. It's clearly a bit of current that scours along the bottom and is creating a bit of scour mark around some of these depressions. It's a little clearer here around some of the objects that stick up, and it's quite clear here. You've got little tails to some of the protuberances. So we maneuvered along on our dive to that first lander, and here is SCAF. Whoops, that's just a still. SCAF is another name from the science fiction series that I mentioned. All of the white blocks you see there are syntactic foam. That's the buoyancy that will lift SCAF back to the surface once we jettison the descent weight. And if you look, follow the letters SCAF down to the bottom F, and then down to sort of the foot of the lander, the frame of the lander. Just to the right of that, you'll see a little something yellow. One of the really cool things Victor did, he went to St. Mark's School in Houston when he lived there, and he invited the students at St. Mark's to invent and build a sediment sampler that he could mount on the landers and take down. And that's the St. Mark's sediment sampler. It was a plexiglass tube about 5 inches diameter, basically shaped like a piece of elbow macaroni. And when we deployed the lander, it was rotated counterclockwise so that it didn't stick below the foot of the lander, and it was spring loaded so that when SCAF hit the bottom, the elbow macaroni piece would rotate 90 degrees and suck up or just scoop up a bunch of sediment. And as you can see here, I mean, it worked. That gizmo is down in the sediment. It picked up a large chunk of a large amount of sediment. Unfortunately, the students forgot that when you're retrieving something like this at the surface, it's undoubtedly going to dunk in and out of the waves a little bit before you swing it up on deck. And they forgot to provide a spring latch that would hold the elbow macaroni in place back on the surface. So SCAF managed to bring the sediment all the way back up to the surface. Everyone was excited to see all this mud in the tube. Then the ship rolled, SCAF splashed into the ocean again, came back up, and all the sediment was spilling out of the tube and making its way back down to 11 kilometers. So partial success and a lesson learned. We had a 4-hour elevator ride back up to the surface. We both ate the second half of our lunch. We watched a movie. We chatted. I might add, just because of all the engineering interest in the audience here, that the transect we planned to make would have been a 4-hour bottom time. And as it happens, we spent an hour and a half on the bottom. The reason is that this sub had not dived for several months. The ship, the pressure drop, had been doing surface mapping and deploying landers to collect biological data. So this was the first dive after several months kind of in layup. And despite a really thorough on-deck check the day before we dove, there was a little bit of seepage of seawater into some of the junction boxes that collect and route all the signals. Seawater will make its way anywhere it can. It's a conducting fluid. I mean, water's bad with any electronics, but this is also a conducting fluid on top of that. And every another atmosphere's worth of pressure helping the seawater find its way into anywhere it wanted to get to. So we got a couple of sort of ground fault alerts while we were on the way down at I think they started around 6,000 or 7,000 meters. Made me wonder if I'd get to bottom. Things happen. You abort dives when it makes sense to abort the dive. But we did get down to the bottom. It was, as we both suspected, likely a creeping progressive set of circumstances that certainly put our bottom time at risk. Didn't put the pressure hull at risk. Didn't really pose any catastrophic risk to our safety, but it was likely compromising and threatening our bottom duration. And sure enough, right after I took that still at SCAF, we got another alarm that indicated that one of our 2 internal batteries had discharged completely. The nature of the fault, the nature of the electrical problem at that point was such that the normal cross scrap from the starboard side that would have trickled and topped up the port internal battery, that trickle charge was not happening because of the electrical fault. So the port side internal battery ran down, and the safety circuits immediately release the surface weight if one of the internal batteries fully discharges. So just after I snapped that picture, we felt the little ka-chunk and realized we were lifting off bottom and that we were in fact on our way back to the surface. I adapted some of the rules of spaceflight, though, and recommended them to Victor, which start with there's no such thing as a bad dive to the bottom of the Challenger Deep. Longer is better than shorter, more is better than less. When in doubt, refer to rule number 1. There's no such thing as a bad dive. This was on about our 5th day at sea. Well, just a couple of stats to remind us some of the contrast with going into orbit versus down into the sea. Takes you roughly 7 million pounds of thrust. That's an old woman's memory for a space shuttle liftoff thrust. I'm sure it's not accurate, but it's on that order to get a space shuttle stack off the planet. It takes a mere 150 pounds of steel to get down to the bottom of the ocean. It takes you 8 minutes to reach your destination on a liftoff and 4 hours to get there in this submersible. The shape of the submersible, of course, will dictate the hydrodynamics and affect that time. Outside the window, you've got 0 pounds per square inch once you're in orbit, and outside our viewports, we had 16,000 pounds per square inch. You know, an African elephant on a stiletto heel standing on every square inch of that sphere. And of course, you've got about 1,000-mile field of view out a spacecraft window, and 0.006 miles reflects the roughly 30 feet that we could see, despite having really an extraordinary bank of lights all around the sub. Everybody loves to illustrate the pressure this way. You decorate typical styrofoam cups before you go. You put them in a mesh bag, stick them in the trunk of the sub. They come back substantially smaller. It turns out what you really want to do is buy very cheap styrofoam because they shrink even further. So these guys clearly, I'm surprised that the shrunken mug on the left is as large as it is for having been down that deep for that long. They should have gotten themselves some cheaper styrofoam. I put MVG on there because I've been having fun playing with the notion that this dive will make me the most vertical girl in the world. And I know that's not quite politically correct with today's Me Too movements and showing proper respect for professional women, but MVG works a whole lot better with the Richard Rogers melody of most beautiful girl in the world than does most vertical woman or person. So I decided, for the sake of the fun song, most vertical girl in the world is fine by me. I did my dive on the 3rd day that we were at sea. We sailed on the 5th. We did preps and maintenance on the 6th. First dive on the 7th. And we then did, that was on a Sunday. We didn't dive again until the following Saturday because of the extensive repair that was needed because of the electrical problems we had. It was a significant hard short that created the cascade of symptoms that we saw. So what did we do in between? We kept deploying those landers. You see another one of them here, CLOSP. You might notice at the left-hand edge of that, a NOAA emblem. I got a full depth hydrophone to mount on the landers because the ocean is quieter thanks to the pandemic than it has been in decades and decades. And understanding the ambient noise environment of the ocean it's really valuable to both marine biology and marine geophysics. So we bolted a NOAA hydrophone onto CLOSP. Here she's going over to the side. We'd put them down early in the morning. It was typically an 0400 wake-up call for 0600 deployment. And we'd pick them up right around sundown. You see one of our Zodiacs that's latched onto a lander and is just babysitting it until the pressure drop comes alongside to hoist her back on board. Partly because my dive only lasted an hour and a half, we did not get to the portions of the trench where there might be rocky outcrops. But on the 3rd dive of our series, Victor did get over there. And this is what the wall environment of the Marianas Trench looks like. Very rocky, very jumbly. If you know your geology and you look at the shapes of the rock outcrops on both images, you may recognize shapes that look a lot like columnar jointing of basalts. That's undoubtedly what this is. It's sort of the classic shape that you get as a lava flow or a magma flow cools slowly. You see some more of it on the right, as well as some yellow patches on several of the rocks, which we're quite sure that those are some kind of chemosynthetic bacteria that's managing to live on those rocks in super cold water at great depths with no sunlight by processing the chemicals within the rocks and in the sediment into their energy source. And then the coolest thing we saw, this is SCAF landed and woke this guy up on one of the dives. This is a little polychaete, also known as a bristle worm. It's probably about 5 inches long. You'll see it's transparent, translucent. I'll try to stop it right there for a moment. I'm going to go back and run it again. He starts swimming. The St. Mark's School sediment sampler is that thing that looks like a wheel that's just above the little white guy. The yellow line just to the lower right of the little white guy is one of the pieces of fiber optic cable probably left over from some semi-autonomous scientific vehicle. So here he comes again. Earlier in the clip, we actually see him come out from under SCAF. The captions for this scene were pretty humorous. Who woke me up? Why are you doing this? But this is pretty typical locomotion for deep sea critters like this, sort of full body undulation. Those cilia, those tentacles you see, are probably feeding devices more than mobility mechanisms. Two examples of the kind of fiber optic cable debris that Victor's actually seen. Victor's done 8 dives in the Challenger Deep now, so he's got the best personal database of observations on the sediment plains and in the wall areas of the trenches. And he's really been astounded at how much of this cable he sees on the bottom. In particular, in the western pool, there's so much there that he's going to recommend to recommend to the scientific community. You got to stop dropping your 11 kilometers of cable when you're done with it and find a way to retrieve it and keep it out of the ocean. And secondly, for future at least manned submersibles, to dive with great caution, if at all, in the western pool, because there's so much of this stuff there. It really is conceivably quite an entanglement hazard. And this is the obligatory happy ship, happy crew. 3 for 3 on the dives we intended. 3 dives in a span of 7 days, when the prior time span was 2 dives in 52 years. Is really a great time. That's Victor playing Leonardo DiCaprio standing up on the jackstay. So that's that's what. Some other things we did in between was we went swimming in the world's deepest swimming pool. We just did a swim call, hopping in for a day, and of course took in pleasant times up on the housetop and some wonderful sunsets. So that's in a nutshell my recent excellent adventure. And let me come back now to all of you. If I can find you again, I'll stop screen share and be happy to take any questions.
Yeah, thanks, Kathy.
Kathy, what was
Either by voice or typing them in the chat window, whatever works best for each of you.
Kathy, aside from the pressure, what was the temperature of the water at depth?
Yeah, the water temperature down there it's effectively 0. Obviously, the water is not going to freeze because of both the pressure and the salinity. The temperature inside the sphere got down to about 22 degrees Fahrenheit. So I had the flight suit on that you saw. I had a pair of nice woolen hand warmers, a ski cap, and I borrowed our expedition manager's lovely down mountain boots to keep my feet warm. I happen to know this is not usually a quiet crowd.
Kathy, this is Kitty Havens.
Hey, Kitty.
I'd like to know if that was the only creature that you saw. I mean, I know that was one you could identify, but about how many different creatures did you see or did you identify when you were at depth?
Yeah, so again, our point was not to do critters, so we were not trying real hard to do that. Victor has supported, when Victor's not diving the sub, he sends a team of scientists out led by a guy from the University of Newcastle, and they deploy those landers specifically to investigate who lives in these great depths. But it's fairly well known for the Marianas Trench because deep and remote though it is, it's actually the best studied of the deep sea trenches. And what you don't see fish, and you don't see the exotic deep octopi like the Dumbo octopus. You don't see either of those below about 8,500 meters. So you're 2.5 kilometers further deep than that. You will see bristle worms of various sorts, like the little one that I showed you swimming around. You'll see amphipods, which they would remind you of the pill bugs that you would see in your garden, except a segmented carapace and little feet off the side. Except that they're usually around they can be as small as a ½ an inch up to 1 or 2 inches. They're albino, they're white, not black. And in very odd food-starved environments like this, you often see gigantism. So if amphipods are usually this big, you've also got amphipods down there that are that big, and they're scavengers. So it's bristle worms and amphipods and very unique forms of anemones, usually quite small and attached to rocks. And what am I forgetting? I am forgetting bristle worms, amphipods. That tends to, oh, and sea cucumbers. That's what I'm forgetting. The sea cucumbers are the critters that you'll typically see out on the sediment surface.
Kathy, this is Bob Wren. Did you see any volcanic vents down there?
We did not see any in the Challenger Deep, Bob. If you move further up the arc-shaped portion of the Marianas Trench, you do see some cold water seeps. So that's, there's geothermal activity below surface that's clearly circulating water around. And in the Serena Deep, which is sort of north of where we were and east, they have found some cold water seeps in some of the biological communities that you find around there. Not in the Marianas Trench, but in some of the other trenches. It's actually, it was the Java Trench, I think. Actually, imagine the seafloor with a volcanic seamount on it that's moving towards a trench. The whole seamount gets sucked into the trench. So that's one of the, Victor made some of the first observations there. But again, the trench environments are subduction environments where plates are colliding and depressing down. The volcanism that produces happens landward of the trench when the ocean plate that's being pushed down gets deep enough that it melts, and that melt starts to surface, but it won't surface where the axis of the trench is. It will come up through the overlying plate. So the islands, the Marianas Islands, that arc of Marianas Islands, those are all volcanoes, and they're created by the melting of the Pacific plate below the trench axis.
Okay, thank you very much.
Yeah.
Hey, Kathy, Bernie Rosenbaum, a follow on to that previous question. I assume these are plate boundaries here, and you're saying that it's subduction. Both of them are going down. That's why the trenches are there, as opposed to one going beneath the other.
Well, the one is the Pacific plate is the Asia plate is overriding the Pacific plate, but where that happens, they both deflect down a bit. So it is the Pacific plate that's plunging down into the mantle, but you drag a bit of the upper one down. So you get some downward bending on the overriding plate as well as on the subducting plate.
Okay, and that force then basically plugs the hole so you don't have volcanic activity coming up from underneath it.
No, what plugs you don't have to plug the hole because nothing's been put under enough pressure to begin to melt at that point. The melting point, the oceanic crust is made of basalt. So you have to take that whole slab of basalt and stuff it deep enough underneath the overriding plate that it will begin to melt. And the fact that it has to get a certain depth before it begins to melt is what sets the distance back from the trench axis where you will see the volcanoes.
And what is that depth where you have melted?
Oh goodness, I used to know these numbers by heart, but it's on the order of 100 kilometers. It's quite deep.
All right, thanks.
You bet.
And so Kathy, is the trench actually getting deeper then since you're getting all the subduction? Is it how deeper is it getting per year?
Yeah, the depth measurements in any of the trenches are not precise enough to really know that, and they're not sampled often enough to really know. So you might be able to infer that from sort of more bulk geophysical properties or by periodic measurements of the spreading velocities and the convergence velocities. It's also hard to tell, how does whatever the hard rock plates are doing, how does that balance or not with the sedimentation rate? So, you've got all those things interacting to set the depth that you would actually measure.
Hey,
Someone asked if the map of the deep is available on Google Earth. I don't know that it's available on Google Earth, but if you go to ESRI, E-S-R-I, that's the leading providers of geographic information systems and related services. If you Google ESRI ESRI Grand Canyons Challenger Deep, they did a great story map, they call it, that is centered around how many Grand Canyons would fit into the Challenger Deep. And you can see, you'll find some 3D bathymetric renderings of several ocean trenches, but particularly the Challenger Deep in Esri's map gallery.
Kathy, this is David Chevron. I had a chance to meet with James Cameron after his expedition when I was in Advanced Development Office, and he had some interesting points about just lessons learned that we could use for doing exploration missions. And I just wondered if you had any other thoughts like that as to how we could do better or better plan those expeditions. I know some of the things he talked about, tracking your location exactly and that kind of thing. Just any other sorts of ideas like that.
Geolocation in the marine environment is a vastly harder problem than in a planetary environment, because sound waves are basically all you've got, and the distances for sound waves are pretty long. And the combination of spreading and scattering, there's a lot more scatterers in your path in the ocean than there is in any atmospheric path. So it's hard. It's very hard to get the precision. And then when you add the depth, that was another real big problem. Is how do you get sensors that can still do what you need at full ocean depth? So we, for example, we were able to get bearing from the submarine to those landers, but we were able to get range, but we were not able to get bearing. So we had to sort of do a zigzag and look for, increasing range or decreasing range to tell if we were on about the right course to rendezvous with the lander. That's predominantly the limitation of acoustic modems and the operations at those kind of depths. So, I mean, he's not wrong. Geolocation is really critical, but doing it through air path or vacuum is going to be way easier than doing it through water.
Mm-hmm. How about other things about collecting samples, or just any things in general that could be useful?
Well, there is a lot of crossover already. I mean, the craft manipulator guys provide both space-based and ocean manipulators now. That some of the operating software, the control logic, and even to a greater and greater degree, the control interfaces are sort of converging. I remember in the early shuttle days having a fairly good fight and fly off with the ocean manipulator guys over the question of whether the split controls that we used with a rotational and translational hand controller was the best way to go for operating the shuttle's arm, or should you use the sort of miniature macro. You've got a little arm that you steer inside the cabin that just amplifies to it's mimicked by the outside one. It's kind of like Mac versus PC. I think it depends on what you start on and what you gain familiarity with. They can both do, they can both become remarkably dexterous in the hands of a skilled operator. I think there's more commonalities than differences. I would be hard pressed if I think back through not just my dive, but all the operations on our expedition. It's the third deep sea dive I've done, but it's the deepest by far. I did 6,000 meters and 8,700 meters, and now this one. I honestly can't think of anything that I would say I spotted in the ocean realm that's kind of amiss in the space realm, or that on the space side of the equation hasn't been thought about or isn't sort of at least on the radar screen already and being dealt with. Okay. Did Cameron think he was offering up something that was like the grand novel discovery?
Oh, the one I remember was just trying to make sure that we knew exactly where we were getting samples from and being able to retrace our steps to go back to those sites if we wanted to and that kind of thing.
Yeah. So in the, not yet in the Marianas Trench, but on some of the volcanic ridges, there are now installations at a few locations that are called mid-ocean ridge observatories. And so they have put down it's not a dense mesh, but they've put down a sparse mesh of acoustic modems so that you can triangulate in and sort of know where you are within a working area. The 8,700 meter dive I did was on one of those ridges, and one of our tasks was to go back to some of these observing locations and pick up the instrument that had been there for a while and put back in its place one that had fresh battery and fresh data capacity. So the ocean world has figured some of that out, even at these depths.
Yeah, and I guess things like cleaning up after your mission and not leaving debris around and that sort of thing would be a good one to think about.
Yeah, scientists are not immune to the out of sight, out of mind. And it's, I mean, it's in fairness to them to say it's not trivial. It's not a zero hazard level to try to retrieve. If you've got an instrument down at the bottom of the Marianas Trench that's 11 kilometers vertical, you've probably got 15 to 20 kilometers of fiber optic cable out. Spooling that out is easy. Retrieving that without fouling or tangling or getting into the ship's props is not a trivial thing to do. But there has to be something that can be done short of just jettisoning it and leaving it to foul the bottom.
Okay, well, thank you.
Thank you. Estella has asked, how long did I decide I wanted to take this great adventure? I last November, and I didn't decide. Victor decided that I was the woman he was going to invite to have this notable first. So all I had to do was say yes, and then watch the ship schedules bounce around, and then pay attention to the blossoming pandemic, and like everyone else, fret a little bit about whether it would still be possible to get to Guam in early June, late May, early June. And my preparation was, be sure you can climb down those 6 steps into the sub, take some cold weather gear, listen carefully when Victor's going through the emergency briefs. I mean, that was about it. If we'd gotten full duration on the bottom, he had promised me a chance to fly the sub, but that was going to be between SCAF and the next lander. So, that didn't happen. But like I said, there's no such thing as a bad dive to the Challenger Deep. If you're going to complain about little things that didn't quite happen, you're missing the point.
Do you have any idea what that expedition cost to do?
Oh, goodness. I think he's got about, short answer is no, but I think he's got about, I forget if it's 43 million in the sub alone, or I think the sub was about 40 million, design, fabrication, everything else. And the refit of the ship, I don't remember ever seeing a number for that. But if you put this all together, we had 6 people, a 6-man Triton submarine crew manning the sub and handling the landers. You've got the full ship's, there were 36 people aboard. So you had the ship's crew, deck, bosun, engine, navigation, bridge. You had the submarine cadre, and you had one expedition manager just keeping all the logistics moving. I would be shocked. It's an absolute flat out guesstimate, but I would guesstimate it's on the order of 75,000 a day, or maybe a bit north of that, to have that ship at sea.
Was there a land-based support mission control room or something like that used?
There was not. I mean, everybody had reach back to Triton or reach back to the home expedition office, but you're autonomous and that's the norm when you go out to sea. You've got reach back if you need it, but you're on your own.
Okay. Yeah, it seems like Cameron might have had X-Pac or something going with that, if anybody remembers. If he had
what going?
Like that, the Expedition Mission Control Center at JSC. I think he was using that for some of the analog work.
Okay. I can't imagine why he needed that, but that's all right.
I think it was just to get practice with that kind of mission support for exploration.
Yeah. What Discover did was engage a company called EOS, EYOS, which is a very small company, I think based in Seattle, and they specialize in expedition planning, logistics, and management. Again, it's a tiny, small company, but they work off super yachts, off Antarctica. It stands for Expeditions, Yachts, Operations, and Services, and they're past masters at complex expeditions in all these interesting areas.
What was the duration of the whole mission from leaving port to returning?
We were out for 10 days. Kitty asked what my biggest surprise was during the expedition. I didn't see it directly. We saw it in the video that I showed you of our little critter, but that we actually got to see a critter up in the water column, moving around, and get to see how he moved. Because again, these are mainly what are called benthic critters. They live on and in the sediment on the bottom. There's just it's pretty well known from prior expeditions to this area that at the Marianas Trench depth, you're just not going to see free swimming critters in the water column. The amphipods will come up off the bottom and swim around a little bit, but I really wasn't expecting to see any macrofauna, and to have this little guy pop loose and dust himself off and swim up through our camera was really a treat.
So, well, I see we have one other Navy guy on board, Admiral Richard Truly. So, Richard, welcome to that. He said that he and you go back a ways, Kathy.
We go back a long ways. Richard was lined up for STS-2 when all of us new babies of the TFNGs came aboard, and then probably my favorite shared moment with Admiral Truly was Admiral Truly commissioned me as a naval officer in 1988.
Yes, I did.
And we planned it out, in the administrator's office with this great view of the Capitol in the distance. And wouldn't that be one of the times that it covered the whole damn Capitol in scaffolding for some repairs? How you doing, Richard?
Oh, Cody and I are doing fine. Colorado is fairly mild in the virus department, and we're thankful.
Yeah. Sylvia asked if I'll do it again, or is there another adventure in my future? So I'm continuing to work with Victor on two projects. One is we're going to produce some more of these ESRI story maps that build off of the video and the data and the experiences, really build more off of Victor's experiences than mine, because the story of this, what he calls the Hadel exploration system, the ship, the landers, and the sub all together as a sort of cooperative set of cooperative scientific tools. It really is completely unique. This was not go to the bottom, say, hooray, I did it, and come back up, or even go to the bottom and spend, an hour and a half or so, as Cameron did, and stuff. We had one short circuit on my dive. Cameron, I think half his thrusters had already failed offline by the time he reached the bottom. He couldn't do a transect. He sort of pirouetted around a little bit. And maybe that's why he thought the whole place was flat, because if you can only see 30 feet in your light, and if you happen to land on a kind of flat area and you just pirouette around, everything you're going to see is going to look flat. That doesn't mean over the scale of the 3-kilometer length of the basin that it's flat the whole way through. But Victor's planning to go back out again. Actually, his next escapade is really hilarious, and it's back to his adventurer kind of route. The actual greatest vertical relief on this planet is from the seafloor off of the big island of Hawaii up to the top of Mauna Kea. That's it, the actual greatest physical extent you could get. So he's now planning to dive the submersible to the deep seafloor off Mauna Kea, surface, kayak to shore, and bicycle and hike to the summit of Mauna Kea. And then he's planning to do some more expeditions in 2021, trench, Hadel Zone expeditions. Again, he's self-funding this biological science program. The ship spent 4 weeks doing detailed bathymetric mapping before I got aboard. That was all self-funded by Victor. All the data are going into the JEBCO Global Ocean Database and over to NOAA. He's then funded 4 weeks of biological work with Alan Jameson out of Newcastle after I got off the ship. That's all going into the literature and into the open databases. So he's going to do some more expeditions next year is his current plan. Again, wants to take notable people, not just necessarily notable big names, but representatives of. I mean, it's been white men and 2 white women to the bottom of the and 1 Asian man to the bottom of the Challenger Deep, for example. He wants to open that up and broaden that participation. And so I was just emailing with him the other day and offered that if he just needed someone along for a great company when he goes back to the Marianas Trench next February, I'd be happy to come along.
Hey, Kathy, what kind of air mixture were you breathing, and how much time did you spend in decompression afterwards?
You're at 1 atmosphere the whole way through, so there's no deco time. And it's basically a standard mix, pretty well 80-20, but you're supplementing mainly with oxygen, so it gets a bit rich through the course of the dive. Interestingly, they use borax instead of lithium hydroxide as their primary scrubber compound in the air handling system. But as you get super, super cold, I mean, if you spend 4 or 5 hours at full depth, the inside of the sub will get very cold, and the scrubbing efficiency of the borax will start to fall off. And so they carry in a couple of sealed pouches lyo curtains, just some sheets impregnated with lithium hydroxide. And if you're starting to get the CO2 is starting to build up, you unpack one of those and just sort of deploy it in the cabin. He's got a couple of clips that you can clip it onto to help suck the rest of the CO2 out of the air.
Kathy,
where was it?
Has Victor not looked at universities to see if they were interested in collaborative research with him?
Oh, he has. The team that Alan Jameson has assembled involves a number of universities. Newcastle, University of Hawaii. So he's, I couldn't give you a full count. University of New Hampshire for the depth mapping because they're a global expert in hydrography. Patty Fryer out of University of Hawaii. I mean, it's a small, the community of biological and geological researchers who are interested in exploring and understanding these depths is relatively small. But many of those leading names have been on his expeditions and or gotten data from him. He's, for all of the, he's obviously a strong-willed and confident guy and a very accomplished guy. He's a very unassuming personality, and he owns the pressure drop. He owns the submarine. He's paying everyone on that ship. And if you were aboard ship, he was a classic case study in wearing your rank lightly and managing through the people that you've empowered, never reaching around them, never stepping on them, you don't step in front of the captain of the ship just because you happen to own the ship. If you're wise, and similarly with the science, he appreciates the value and importance. He appreciates the good fortune he has to be able to supply this opportunity for the science. He just wants the science done by the best names, the best talents that he can bring along to do the work, and he just wants them to publish and get the data out into the universe. So he's not a hoarder, and he's not trying to pound his chest and take personal acclaim and personal credit for the scientific work that he's enabling. Yeah, I see David applauding. I agree. By the way, I thought I would share one other thing with this crowd. You will all recognize that. And I could not resist. I had that made. So 10 kilometers plus with the limiting factor. And as soon as I figure out what goes where on my flight jacket, I'll have that to go along. And you have to have a mission patch. So I had that made up. The S is, it's my own personal logo, signifying sea and space and my name. And then a shuttle going up, limiting factor going down, the astronaut symbol here, Neptune's trident over here, and most vertical girl in the world.
That's very cool.
You got to be able to laugh at this,
So what was more fun, going to the bottom of the ocean or doing an EVA in space?
Well, it kind of depends on your definition of fun. If sort of have no responsibility, go along for the ride and enjoy the view, then definitely the submersible. I mean, you know, eat lunch, watch a movie, and see this amazing place. Got it. You know, it was great. Truly amazed. You know, I'm a pilot as well as an oceanographer and everything else, and you kind of can't beat being pilot in command of your own craft. And you go out on a spacewalk, you're pilot in command of your own very own body-shaped spacesuit, and that's just very cool. You know, I love MacArthur's default picture of him hanging off the end of the arm. That's a great shot, Bill.
Yeah, Kathy, Bernie Rosenbaum again. I have a good picture of you off STS-45 when you're working the ORS out there with Dave Leesma.
Yeah, it was hard to get any decent shots of that. We were, you know, 60 feet away, two little white dots against all the white installation of the ORS. It was a tough photographic challenge that we left for our crewmates.
Both you fellows back there working at it, so it's a pretty good picture. I'll have to get you a copy of it.
Yeah, it'd be great. Glad to have it.
Okay, I'll get it to you.
Hello, Marianne. You're mute. You're on mute. Marianne, you're on mute.
There.
Technically challenged.
Yes, and I had a problem getting on in the beginning because I think it's simply because the interface is so slow here that I'm too anxious. But I'm doing great here from Denmark, and I love seeing everybody. It's great. I'm sorry I missed the very start of it, but it's great to see you. And of course,
great to see you.
I think about the first shuttle flights and with Dick Truly there. I give a lot of talks, and I usually have that picture with Dick Truly standing behind me in the mission control with me. And the TV has been crazy about me right recently because of the Mars, the 2020 rover, and then the return. So I have been on Danish television. There's nobody like me in Denmark.
Yeah, very good. So another question was, how high did we let the CO2 get? I think it got up to 8 ppm, so we were doing fine. It probably would have we probably would have had to pull out the LIO curtains if we'd made the full 4-hour bottom time, but with the electrical issue, that became a non-issue.
And you said you made 3 dives.
There were 3 dives done on the expedition that I was on. I did 1, and Victor had along 2 other, you know, mission specialists that did the other 2.
I see. They went to the same place?
Yeah, roughly the same place. All in that eastern pool. You know, a different line each time, because you're trying to, you know, get a sense of the bathymetry through the whole eastern pool.
And you said CO2 got up to 8. What do you mean by 8? Is that 8 times the normal amount?
No, if I remember right, it's
400 parts per million is what it's supposed to be in the atmosphere now, and below 150 or so we die. So, or I mean,
yeah.
Earth dies.
Yeah, I'm not remembering what units it was in.
8 might be 8,000s.
Could be.
Okay, that would make sense.
I mean, it was basically the same kind of measurement we had on the spacesuit for, you know, CO2 inside the suit.
Hey, Kathy, I think what we looked at was millimeters of mercury.
There you go.
You know, in the cabin, and so I think at one time, although it's lower now, we would allow up to 7.6 millimeters of mercury, which is actually pretty darn high. But anyhow, I think we try to keep it down below 4 or so on ISS now.
Okay. Yeah, I think we were planning. Again, this is from memory. I don't have my logbook and notes with me. If it went above 8, I think we were going to pull out the LIO curtains, and it never got any higher than that. And again, we were on our way back up through to the surface, so you're getting some slowly some improvement in the temperature that lets the borax kick back in. It's hung in there enough to keep us at a safe level. Y'all are challenging my memory. It's not fair.
Well, I'm curious about the conversion of millimeters of mercury to parts per million. Somebody out there probably knows that.
I had to be on my pay grade.
Thank you.
You're welcome.
So definitely more fun going to the bottom of the ocean and running a big Washington bureaucracy.
I don't know. I had a very good run at NOAA. Pulled some satellite programs out of the ditch, got repaired seriously broken political relationships with the White House and the Congress. And there was a huge schism between the politicals and the careers. When I came aboard, we turned that around pretty quickly. So that was it was a great run. But yes, the sub dive is definitely, in the pure fun sense, yeah, definitely.
Hey, come visit us in Denmark at the Danish space program.
You, as soon as you fix the pandemic, Mariana, I'll come over.
Oh, it's very low here.
No, but you have to fix it everywhere.
Oh, good.
Oh,
No problem.
No problem. Well, Stokes, I have to give another talk, not too many minutes from now. So I probably better wrap up and thank everybody for joining this, and thank you for the invitation to tell this tale and share my latest vacation story.
This was really a treat for us. I mean, we usually go above the earth, not below in our talks. So this was really a treat. Thank you very much, Kathy.
My pleasure. Great to see so many familiar faces and names again. Thank you guys for joining.
Thank you, Kathy.
Thank you, kid. Thank you, Kathy.
Thanks. And for everyone else, we'd like you to tune in next month. We're having a great discussion on September 3rd for the first Thursday. Dr. David Crean from the Lunar Planetary Institute is going to talk about going to the South Lunar Pole on the next, for NASA's next objective, where we're sending humans. And it's a really interesting speech. He gives the hows and the whys of going to the South Lunar Pole. And then on October 1st, the branch chief of the Environmental Sciences branch at JSC, Torin McCoy, if anyone knows him, he's going to give a speech on, or a presentation on lunar dust. That'll go along with the lunar South Pole. So we got two really interesting presentations coming up, and I hope everyone can tune in. Meanwhile, thank you very much, everyone, for tuning in. This was a great time, and we'll see you next month.
Well done, Stokes.
Yep. Thanks, Stokes. Another home run, buddy.
Thanks.
Thank you.
Thank you.
Thanks.